Model T Ford voltage regulator. Okay, this is my next experimental circuit, and I'll just run through how it operates. Okay, the basic principle is the grounding switch and the diode cutout. So generator current flows through the diode, which acts as a cutout, and into the battery, which is all standard practice. And when we want to stop the charging, this MOSFET here conducts short-circuiting the generator. Now, short-circuiting the generator is a perfectly acceptable means of control because it's a third brush generator which acts as a constant current source. So when it's short-circuited to earth, the field coils are robbed of their supply and it produces no current, so it's perfectly safe to run it that way. Alright, so to ground out the generator we use this MOSFET, and that's controlled by the LM393 comparator. Now, the voltage reference is a red LED which provides about 2 volts reference, and it's a relatively stable voltage in terms of temperature variations and supply voltage variations. So the lead is run just off a 470 ohm resistor off this supply rail here, which I'll talk about in a minute. Now, to the other input of the comparator is a preset potentiometer, and that sets the voltage at which the comparator switches on, turning on the MOSFET and short-circuiting the generator, which then stops the charge. And there's also a hysteresis circuit here, 220k resistor, which provides a little bit of positive feedback so that the switch on voltage is slightly higher than the switch off voltage, and that's to provide a very clean and definite switching point. Okay, now this supply rail here, because we're measuring the battery voltage, we can't just leave this connected all the time, because these resistors and this resistor and the LED would put a little drain on the battery, which over a few days wouldn't matter, but over a long period of time it's not a good thing to do. So these two transistors here are used as a switch to only switch the regulator circuitry on when the generator is running. So how that happens is, when the generator starts rotating, because of the residual magnetism, there will be some voltage output, and through this base 10k base resistor, this BC548 transistor then switches on, and in doing so the collector current creates a base current in this PNP transistor BC558, which then switches the battery voltage to this supply rail and powers the whole thing up. Okay, so let's demonstrate it. I've got a real battery this time, and instead of the generator I'm using a 10 amp bench power supply and a 12 volt 36 watt light bulb to limit the current, because the current limiting on this power supply is not adjustable, it's fixed, so we want a little bit less than 10 amps for this test. So I just switch it on. Now we can see that the battery voltage, if you can just see it there, it's beginning to rise up. And I'll just pause this for a moment and we'll come back when the battery voltage has risen up enough for it to start operating. Okay, we've got about 2 amps of charge current, and you can see as the voltage comes up to about 7.13 volts, the MOSFET switches on, and you can see that the charge current drops away completely. And as the battery voltage falls down to around about 6.9, the MOSFET switches back off and allows the charge current to flow again. So the cycle just keeps repeating, and by this means the battery voltage is limited to, well, in this case about a bit over 7 volts, which is what you want for a 6 volt lead acid accumulator. So there it is. I suppose the next step is to build this into a form where I can actually put it into the car and try it out.